Yeah, with that I will quickly just introduce myself. My name is Bala, working as a Principal Solution Engineer in YugabyteDB since 3 years. Thank you once again for all of you being here. So it's the last session for today, so I will also not bore much of you with that. So I will just straight away go to the topic. So today we are going to talk about how do you deploy application globally with the different design patterns using YugabyteDB as a backend, right? So as you are already developing applications, so when do you think, maybe if you please give a slide. Thank you. I don't know, it's a all right. Okay, so you already knowing some of your global applications, maybe knowingly or unknowingly you may be keeping it in your app, either from your mobile app store or from your Play Store, right? Or maybe in your laptop. So you don't know that is a global application. You may be still using it like in your laptop, you thought that may be a local application. Actually speaking, those are like global applications, right? So these are all the global applications which you are already using it today. So like Spotify, or maybe Fitbit, or even TopTal, right? Some of the Slack. So these are all already been built it with the design pattern of global applications. Why global applications? Because it needs to take care of the 5 key things when you are saying that your application is ready for global, right? When you are saying that, okay, this is enhanced connectivity, so that means it supports different clouds or different hardware, or maybe with the different databases, right? So it has to be agnostic to support different sort of data centers and different sort of geography and all those things. And this is where you can able to expand your business, because when you are not making your application globally, you don't say that my application will not work on certain country, then naturally you are ignoring that country, or you may be not taking care of those customers who are belonging to that country, right? So that's a sentiment that country may put you on that application when you are saying that this will not work. Simple example, if you go to Singapore, Uber won't work. Either you have to be in Grab or some other application, right? Wherever, so because it may be either the regulatory requirement of the app is not certified, or maybe because that is not been popular or not accepted by the customer also, right? That's how the global applications are having their own challenges also. So if you see the third point, innovation and collaborations. When you keep saying you are reaching the global scale or a global application, you should always constantly bring the innovation and keep the features integrated. Then only you can say that your application is ready to take care of a global customer requirement, and it is also globally rolled out, right? Then the last 2 points are mainly to access to services. See, it has to take care of not only your local requirements, but also has to be work for agnostic to when you move from one country to other country. It has to give the similar sort of services and everything. More important, it has to be real time, so that it should not say, okay, you just press a button for a car booking in India, it is coming in 2 minutes, but you are sitting the same app or using it maybe from Europe, it is taking 15 minutes. You may feel differently because you are thinking like, what the hell, why this is taking 2 minutes in India, in 20 minutes or 15 minutes in Europe, right? It may be because of data issue or a data access issue, correct? That's the next thing what you may be thinking of. Now we are going to talk about design and deploy patterns of global applications. So you may be knowing already some of the concepts. I'm not just going to spend much time on this. See, we are already in the modern world or modern era of using in a ChatGPT world. So you are already having your application with these design pattern. Somehow you are using any one of these pattern in your application life cycle today, right? So it can be either a microservices pattern, or maybe starting with the last one will be your Strangler Fig pattern also. So each of the applications are being already highlighted with an example. There are many applications, I didn't put it because of the space, but I just took like who may be the first person started using it, or who may be the first person doing it. So here you can see some of YugabyteDB is also falling into one of the pattern that is called the data sharding and the replication pattern, right? So if you want data to be globally distributed, where you want to keep the data across the geography, so you may be thinking of like how do I and which pattern I have to use, right? So that's the reason Yugabyte is coming to the picture even to help you on setting that one. So then you maybe got confused, is YugabyteDB is a database or application, right? First of all, YugabyteDB is a database, but it supports plenty of topology to keep running your global applications with a different scale, with a different resiliency model, with a different access pattern. So just go back to the definition of YugabyteDB. It's a globally distributed database, and it is mainly meant for cloud native workloads, and it is supporting two sort of workloads. That means either you can bring your NoSQL workloads like from Cassandra API, or you can even bring Postgres sort of workload with relational workload, you can support that, right? So it's again completely open source, comes under Apache 2.0 license. If you might have already heard the discussion today morning from our CEO, he already explained the ultra resiliency part and how YugabyteDB is really beyond that space. I'm not going that detail of what is YugabyteDB. So let's come to the designing the global applications. So come to here, right? You may be thinking many decisions has to take when you can call your application is globally ready or globally going to meet the requirement. So these are all the three aspects, right? First, it has to comply to your architecture requirement. Second, it has to comply to your availability requirement. Third, it has to comply to your data access requirement. I will just spend a time here and just explain what is architecture requirement, because where the app is going to be deployed. So you may be thinking of concentrating on three geography, maybe Europe, US and India. If you are thinking app is going to be deployed in India, definitely you may be incurring more latency when your customers are spread across US and Europe, right? How it work? Will it work for across geolocations? It will work perfectly, but the challenge is latency is the penalty, right? Availability requirement. How will the app behave on failure? Suppose a customer who is accessing data, suddenly the network broke, or maybe it is not able to serve the requirement properly to that customer. How it will work actually? Will it operate on all the data or subset of the data? These are all the things may comes into your mindset, right? So do I need all the data to US, or I can just see what data is available in US, I can still serve the customer. Data access requirement. This is very important. This is because your access pattern is going to solve most of your problem on how you can develop your global applications. Whether I'm okay to do a read in one place or write in another place, or I have to do read and write on the same place. Am I okay with the stale data? Am I still needing a real-time data? These are all the thought process has to come to you first before even thinking of how you can develop a global applications. So some of the jargons, I just put a legends so that it will be easy for you to relate here. So it will be a tablet leader, tablet follower. So those things just to highlight you, so that the next slides are going to carry a lot of diagrams on these things. So let's look at the application architecture first. So this is a single active application. So when I say single active application, so this is going to be like it is active in only one region. So say for example in this case I just took US Central as a region. So the data placed close to the apps, all the other apps are standby, right? You see the dotted arrows only, there is no read or write or anything happening. Those two, US East and US West, are sitting just like a empty machine without having any app connectivity, but the data getting replicated across those two data center. This is a traditional architecture we follow even now in some of the banking. They call it as DC, near DR, for DR. That's exactly the model. It's called a single active application. That means both your read and writes are heavily happening on your US Central application, central data center, right? Now multi-active. What is multi-active? I can deploy an application server in all the places. However, my application is connecting to again to a single data center because that is my DC. So where I am just saying that all the data are pointing to this one. That means my US Central is going to be a leader node, where my US West and US East are going to be a follower node, as per this architecture what Yugabyte supports, right? So that means the writes are happening here. The reads can be even, you can read from local read on both the sides also, but for the arrow mark you are seeing, all the writes are happening entirely on this one. This is multi-active. Okay, this is good, but how do I do my local read with this pattern? So this is another pattern already you may be using in different databases. So you have something called master-slave architecture. I do my master only for read and write, which is required for an application. I will take my slave for like a replica, so where I will just do my CQRS pattern. I will transfer all my workload directly to my other slave itself to do the reads. So this is called a local read or read-only multi-active. So this way, like suppose I have a workload of 1000 TPS, 800 are write, 200 are read, then the 200 can be served between those two nodes, 800 can be served on the central node. So this is the read-only multi-active. This is another architecture where you may be using it right today. The last one is partition multi-active. What is partition multi-active in this case? So you are actually operating on subset of the data. What is subset of the data? I have a global customer. In this case, I may be having a data partition for my US Central, US West and US East. So just for time being, you remove the US geography. Think of like this is India, Europe and US. So you may be operating India customer data, US customer data and Europe customer data. This is the subpartitions or partitions of the data that you are operating it on. So this way, this is called geo-partitioning. So where you may be doing again, those partitions are being only getting read and write on the respective data center. So this way you are locking the partition to work for only those customers, making sure that the read and write latencies are going to be very low. So this is another pattern you may have to think of. Now we had seen the first one, application architecture, then the availability part. Availability is very crucial for global applications. Like I said, in case if you are going to a remote place or even a place where you have a good connectivity, but your app server is too far in another geography, it may be paying more penalty to the latency. You may be getting a very slow performance on the application where you don't like it, right? So you may need to think of what I am doing. So why don't I bring my database closer to my application server or where the customer is standing on the location where he is currently accessing it, right? So this is where app and data has to move together, right? So this is what we call it as follow the workload model, right? So this case, how do I do that is, in that case, say for example, if one of my data center goes down, so I can still keep my, as per the Yugabyte architecture, it's a leader and follower. Then one of your follower is naturally becoming a leader. That means in this case, you can call it as a standby becoming your active node. Here app and data are together, all going together. That means it's no subpartitions. All the places are having all the data, making sure that you are fully following the distributed database pattern from the availability perspective, right? This is geolocal data set. So this is where some of your very specific requirement, like example like banking or maybe healthcare or maybe some of the any specific use cases where you will not do cross-border transaction or sharing the data is strictly prohibited. Think of like in India, RBI is putting a tight spot on the customer. The same customer is also available in Singapore with the MAS as a regulator. In this case, what you are doing, making sure that, or I can take maybe Europe, right? So in this case, Europe is having their own FATCA requirement. So both customer can able to do their transactions separately, but never they will share the data each other on the database. That means it has to operate only on this cluster. This has to operate only on this cluster. That means it is called a data residency requirement or a data locality requirement. So this ensures that the data is not going to be available outside of their periphery or outside of their geography, right? So this is another availability part. This definitely complies your regulatory requirement. Availability part, if one of my node goes down within that, can I able to survive with the two? Perfectly you can survive, right? Because this is anyway the leader follower model, one of them can be again elected as a leader, then the two, anyway quorum is 2 is required, 2 are there, still you can operate that one. You can increase even more nodes also. If you have more workload on USA, if you have even less workloads, you can still continue with the 3 node in Europe, that's not a problem here, right? This is another pattern. Now last one on the decision part, we had seen data access architecture. This is where you need to put more attention how I am going to take care of my consistency on the read part and the write part, right? So I'm going to read from source of truth in a cross region, right? So I'm reading, you see, all the apps are pointing to US Central because it's all are pointing to leader node. Think of like US Central is your leader node. So even though the app which is sitting in US Central will get low latency, whereas the other two will always go for a high latency because already 40 millisecond, 30 millisecond is the network latency which you have to take care of your query part, right? So this is another way. No, I don't want that way. I want still, anyway the copy is available in the respective region, why don't I do my local read or follow a read? So Yugabyte supports that, right? Yugabyte, you can still go to the respective node and you can do follow a read. The only condition or the criteria here is you will be reading a stale data, right? You will be reading from the replicas. So the reader are closer to your region, you are doing a local read, latency is going to be low, you have to take a condition of if you are okay to read the stale data. That means if you are writing something, the data may not be immediately available, maybe a lag of millisecond or maybe a second latency, if you are okay to read that, right? That depends upon your application design again, right? How you are going to take a call. This is anyway common pattern which you all know. How do you do the read replica? Either you can read from the stale data or from the replica, which you can just do it from the latency, right? This is the thing. So before that, I will quickly show a demo. We just see how we seen all this diagram. Let's run a quick video and then I will talk about this design patterns. Can you please? So this don't have a video with audio, so just a video only. I will just explain it after it completes actually. So this is the Yugabyte managed, you are signing in. Okay, so as soon as you go to cloud.yugabyte.com, you are able to sign in with your any social logins. So let's say I am using my organization ID. I am entering into this. I can even able to add my cluster with the free tier or my paid tier using Yugabyte. One of the lab exercise, we just put it as a global cluster. We are going to create it, right? So which is for the global application we created. In this cluster, so there are 3 design patterns we are going to cover. So we just launch the lab first, right? So before that, let's understand what this exactly is going to do that, right? So this is helping you to run a simple global application with a different design pattern. So either with node with a single region or multi-region or geo-partitioning. Let's see all of them in the demo, right? So what I'm doing here is, in the background, it's already created a cluster in GCP, okay? Even though it's a lab, it's not like a, what do you call, like a video only. It is actually running some resources in the background. So let's say the first case is US West is my single region cluster, right? So you can see the resources. Similarly, for a multi-region with read replica, multi-region I have a 3 region in US, and this is the data part, what I'm just going to run it with the 2 tables, right? Let's run the lab and just see that. In the single region, I'm just taking US West with the 3 nodes. Okay, it can be 3 AZs of US West. So the first and foremost, I'm carrying a mobile, I'm going to pick a location. So as soon as you see, right, so my location is going to be in Los Angeles, let's say that's my phone location. So what I'm going to do here is, so let's say, I will just choose the location as Los Angeles, right? That's my location, phone location. So now I'm going to do my read part, right? I have my product catalog. I'm just pulling my product. You can see where my location is. You can see clearly where my phone is also and what is the latency which I'm incurring it, right? So it's read. Anyway, the data is coming quicker because I'm close to my data center also. It's perfectly fine. Now I'm going to do write. I'm adding into the product catalog. I'm going to enter that book, whatever I purchased. So this is the Yuga Store application, we call it, right? So here I'm just moving into the by part, and straight away you can see the insert statement with more latency, right? Why? Because insert has to do 3 replicas. So behind the scene, it has to write 3 copies. So all those things are happening. All good. Now this is perfectly working. Take a location where I am in Mumbai, okay? Even though my data is available across the globe, now I am in Mumbai. My phone is in Mumbai, but my data center is still in US. See the latency travel. Now I'm just selecting a product. It is 440 milliseconds, right? Such a huge thing. So again, some 221 milliseconds to search a book. So this is the difference between a 3 millisecond or 8 millisecond when you are close to this one, where you are traveling all the way to the other side, where your penalty is high latency, right? This is where a single region, really good for local read and write, but when I am moving my application still away from my another geography where I am incurring more latency, right? This is one sort of a pattern. We just seen that. Now, you see even the write operation, you see, it's close to 243 milliseconds where you are saying that, right? Because the write is also more. Read is also more, write is also more. It is not in single digit milliseconds. What next to be done? So this is now single region is not serving across the globe, it is serving only within the globe. Can I add some read replica if the customer is far from US, who all are in Mumbai or maybe in London? I can go for another 2 plus 2, 4 node read replica sitting across another 2 locations. So now my cluster is going to be a bigger cluster. So I have a 3 node, 3 region US cluster, but I have a read replica also. Now I am going to operate the same way. Let's say I am operating from Los Angeles. My latencies are in singles milliseconds, and whereas my write is also going to be in sub-milliseconds, because it is not going to give any penalty to my latency perspective. You can see clearly it is coming very close, right? So let's do the operation of even finish the buy the product catalog. So where you are clearly seeing that the read and writes are going to be lesser and lesser only, right? It never go more, right? So let's see now. Let's take another location, right? Let's say now I'm moving or roaming to Mumbai. Now I am going to use the same application, right? So let me just choose Mumbai as a location. So if I choose Mumbai as a location, now I'm going to rely on my read heavily from my local read. So you see the latency now, where it was 200, 300 milliseconds, it has been brought down to sub-milliseconds of 2 milliseconds. Because my database is anyway replicated with read replica, I'm still operating from here. It's the same cluster. I'm not just creating another master-slave architecture. I'm expanding into primary to the read replica. It is all happening in sub-milliseconds like US, right? So you can clearly see my data center is here. My phone location is in Mumbai still. That's what we are keep printing in the explain plan. Okay, now let's see the write part. Is write is going to help in read replica or no? Because write is definitely not going to help in read replica, because write always has to go to your primary, correct? Write is always has to, that's why you have more latency there. So how do I avoid that? Even write also I want to do it in local, right? That may be the next pattern we are going to see that. So where you have to keep your local read and local write. That's a third pattern we have to see that, right? So let's see that. So in the third pattern, what we are going to see that this is a multi-region read replica we had seen. The third one is going to be 3 different geography, US West, Europe West, here Asia. 3 are going to be 3 primary clusters, right? So this is called geo-partitioning or geo-partition cluster we are calling it as. Here this is going to help you to do the read and write respective region only. So this way global applications are really going to help you to reduce your latency. So if for example Los Angeles, I'm reading and selecting the catalog of books coming in sub-milliseconds. Now I will go to Mumbai also and do my read and write also, or even in Los Angeles I will do the write also. Let's see the performance. Yeah, so now I'm just buying the book. Let's see the insert. Even this is still acceptable, right? It is not too far or something, right? So it is okay to see. Let's look at the Mumbai part, right? So now I'm going to just test it, my mobile to Mumbai. Let's say I'm pushing my request to Mumbai. So where I'm currently deployed in a Bangalore cluster, but my phone is located in Mumbai. So let's see, this time I'm pulling a catalog where I want to see the Mumbai. It is all coming in 2 millisecond and 5 millisecond. Let's look at the write also. So as soon as I just selected the book, let's say from the cart, if I'm checking out, how the performance is going to be, right? Yeah, so this is now let's see how it is going to really solve the write part. Because the read part we know, because see, write part is now coming in sub-millisecond. This is exactly what we call it as geo-partitioning, right? Or row-level geo-partitioning. So with that, many design patterns are there. So how we have to follow when you are using Yugabyte. So Yugabyte supports single region, multi-region geo-partitioning cluster. Even with the geo-partitioning cluster or a multi-region cluster, what are the design pattern that you have to follow? That's something where we have to say that, right? So this is the third location even we are testing with London. Even though my servers are in Frankfurt, we are even testing the third geography. After we tested from Mumbai, we want to see whether the records are still happening in London to Frankfurt server, or is it going outside of their geography, right? So let's see the latency, right? So this is also happening, again sub-milliseconds. So even the checkout, if you are doing it, the insert is not going to be high. So it's very clear that the read and writes are happening with the geo-partitioning cluster locally and taking out all your penalty of writes, particularly even though you go with the read replica cluster. So this solves the problem. Will it be enough to go and say that my global application is ready? What are the other parts that I have to keep in mind when I'm going to build my app, right? So that's the next part we are going to see that. Can you please pull it out? All right, let's see the design pattern, right? So these are all the design pattern when you have to think of global applications. You have to think of a global database. Is it something global database is mandatory? Can I do app level sharding? What do you mean by app level sharding? I know my application is going to be launched in 10 countries. Why don't I create 10 databases? Each databases can be one for each country. I will just keep the same copy of the schema, pointing my application server to that particular data server. I'm not sharing the data across the DB. This is called app level sharding, correct? This is already been happening today. App level sharding, what is the risk? Small schema change, you have to replicate all the 10 databases. Small schema changes, all the 10 applications running on 10 geography has to be do the regression test. Do we have the time today to do all those things? We don't have time. Even if one breaks, your reputation will go for a problem because you are working for a global market, not a local market. As soon as you are globally failing, local market also will come to know, right? So this is the problem today from the applications, from the awareness perspective, the application is gaining familiarity. Also it gains the popularity with the low rating immediately if your application behave badly, right? That's why global database is one of the design pattern you have to think. I will just create one database, let it replicate schema, let it also take care of all the changes seamlessly. I don't need to worry. That is one part. Second part is duplicate indexes. What is duplicate indexes? Just to avoid the latency penalty, I can create some region level duplicate indexes where my read can go only to that particular region where I can avoid creating n number of read replicas. That is going to reduce my cost. Third one, active-active single master. Active-active multi-master, active-active single master. What is active-active single master and active-active multi-master? Active-active single master is going to be only one app on my one region is going to do, whereas I want to do suddenly if my app traffic is peaking high, I want to even transfer the traffic to my other side of the country where that also has to take care of my write. So that means you are just doing the load balancing with a single app. Multi-master, this is going to be another interesting thing where I want to even keep both my app running in both the data center by having US also in India. I have my app currently running in US also, running in this one also, but data are bidirectionally syncing each other. So this is active-active multi-master. There are other patterns like latency optimized and locality optimized. What is latency optimized and locality optimized? Latency optimized is something like you have 3 regions within the country. You can just do a region with the pinning called leader pinning, we call it. Let's say US East. You also have US East 1, East 2, and you have a US West. Knowing the proximity between US East to East, or think of India, right? We have in India AWS 2 regions, one in Hyderabad, one in Mumbai. But in Mumbai we have 3 AZs, Hyderabad we have 3 AZs, let's say. You are designing a cluster by pulling 2 AZs of Mumbai, 1 AZs of Hyderabad. In this case, what you can do, with this latency optimized geo-partitioning, you are clearly saying my leader has to be in Mumbai, never going to be in Hyderabad. This way, you will be avoiding the latency part. Why? Because Mumbai to Hyderabad latency is already 19 milliseconds, which you don't want to take your right to go for high latency. You can reduce the latency by pinning a leader or preference leader configuration is there in Yugabyte. Okay, what is the 6th one? Locality optimized. This is exactly where regulatory requirement force you to do the read and write only in local, what the Yuga Store application, what I just meant. Like example, healthcare customer, they never allow you to share the data outside of India, or they never allow the share the record out of another country, right? This is where you have to keep your local reads and writes specifically with the locality optimized. This is where your GDPR compliant will come, FATCA compliant will come, HIPAA compliant will come, right? Whatever you name it, right? This is also have to be compliant with the global database. These last 2 are already known thing which you are using it. Either if you are using Yugabyte, you can just put a set follow a read, you don't need to go to the leader. Let's say leader is too far and your application is closer to the follower, do the follow a read, which you already seen in my diagram. Read replica is also known to us, where you read from the replica, not go into the leader to avoid the penalty, right? These are all the pattern you always have to think of it. So let's go on deep dive. In the interest of time, I maybe just talk about the key things. I will skip the follow a read, read replica, but I will just talk about the other things, right? So you can think of active, single master and multi-master are already familiar, right? You may be using Oracle today. You may be either using Data Guard or Golden Gate to replicate the data between the two data center. Or if it is an Oracle rack, you may be using it this today with your DCDR. Similarly, read replica, if you take even MySQL or Postgres, it supports read replica, right? Either primary or read replica, or even your RDS, you have the concept of adding a replica node, right? So let's talk about one by one. So first thing, single active, right? Let's say my application is here. These are all my application part. The data part is here. So I need to ensure my data has to do consistent read, follow a read, read from nearest location, or read replicas. These are all the patterns I can go for it. However, I just want to see from follow the work field or maybe the geolocation data set, right? So in this case, either I can go for a global database, active, single master and a single thing. Even multi-active, I can go with the global database and duplicate indexes. What is the difference between single active and multi-active? I will repeat again, right? Let's go and see the diagram here. Single active and multi-active. So in this case, this is single active. 3 regions are there, US West, US Central, US East, and latencies between the regions are already shown, right? So in this case, what it is doing, so the data is actually, you have a global databases, you already put it. You created a customer table, it is replicated across all these regions. So what is happening here is, you are keeping the leader pinning, where you are keeping the replica here, which is farther there, right? So where you have to place 2 copies closer to these regions. So knowing that US East to US West is 60 millisecond, I don't want my quorum to be formed, or I don't want to heavily load my West cluster, where I can keep my these 2 closer cluster or closer node to be heavily do the read and write. In this case, it's a single read or single active requirement. In this case, what I can do, my preferred region is US East, preferred region 2 is US Central, preferred region 3 is this one. Let's say if US East go down, Central will be elected as a leader. Till East comes, that's the only node, it has to take care of that, but that's not going to impact your performance. Why? Because it's only 40 milliseconds, where there is a 10 millisecond lag might increase, right? So this is called preferred region concept with a single active, right? So in this case, app in East is taking 2 millisecond and write is also taking in 30 millisecond. So here in app also taking 2 millisecond and write is also taking 40 millisecond if the East goes down. So now the closer regions, right? So this is what we call it as the closer region is, you have to pin how accordingly. So in India, we don't have a choice, because today in India, we have only, Azure is having the 3 regions, right? Either Azure, Central India, South India, or maybe West India. So Central India is your Pune, West India is your Mumbai, and South India is your Chennai. But in Pune, Mumbai, always you have to choose this. Chennai, you have to keep it farther, because Chennai is always a high penalty on the latency, right? The same concept you have to choose. When to choose this design pattern, you are going to give a standard deployment. Most users are located in one region, because this is single active. So let's say my density is heavily in Mumbai, or maybe my density is in the central region of the India, right? Our users are distributed based on the preferred region. You can even route it through your load balancer. Replicas are for high availability or failover, right? This is a design that you can choose for your application has to go for this pattern. So applications are active in one region, so low latency read definitely. Write latencies are higher. Why? Because it has to get the acknowledgement from the next region, which is little far or maybe closer, right? That's where we need to go with the preferred region or a leader pinning concept to reduce that write latency also. Here application factor can be 3 or 5, again automatic failover and 0 data loss. Now let's look at multi-active. Single active is okay, let's look at multi-active. So multi-active, again, I think you might have heard today's morning from our CEO, Paramount Plus is one of the streaming company. So they followed this pattern, right? So they deployed their application across US. So where they just took the architecture, as you can see, west, central and east, right? So they just put it here. So in this case, if you look at it, so what they did is to reduce the read latency, because read is going to be really high for their requirement, because as soon as the customer log in, read has to come very fast. So in this case, 3 regions, we created a duplicate indexes. Duplicate index is good for certain use cases if you have heavy read, right? So it is not bad pattern, but still it is helping you to reduce the latency, because you are creating the duplicate index in 3 regions. So in Yugabyte, index is nothing but a table. You are not actually thinking like an index is another file like your bin log or something like in Postgres, right? So it is going to be another table again that can be sharded. So that is how it is improved the performance of the multi-active, right? So in this case, duplicate indexes can be created in 3 places. So maybe if you look at it, my app is reading there. So in this case, my application is taking 30 milliseconds for the access, and write is 60 milliseconds. How I can reduce? Now a customer is even going all the way to west to east, 60 milliseconds, it is going to take more, right? How I can avoid that? I can create a duplicate index. You can see I in all the boxes. If I'm just doing my read here, you see access is 2 milliseconds, because it is quickly reading from the index table itself. We call it as a covering index. Whatever the query you wanted, you put it in that index itself. That will be treated like a table. Let's say I need 10 columns, all the indexes are going to hold the 10 columns. This way I am reducing the latency, right? This way I am not going to again hit my east server. I am doing it from the local itself, right? This is another way to reduce the latency. Here, consistent read, that is a message is clear. When to choose? You have a consistent read in all the regions. So where you have to make sure that your reference table that do not change often. So your schema should not keep changing it. Otherwise, you need to wait for the schema to replicate. Otherwise, you may have incur some discrepancy or disparity in schema where your query may fail also, right? So that's where you have to take a call on these caveats when you have this one, right? So applications are active in all the region. That means I have US East, West, South, all the 3 places. Only one duplicate index only is recommended, not many. Again, consistent reads and low latency reads, high rate is okay for you, right? Because your read intensive application, this is a perfect pattern, we can go for it. This is the last one, latency optimized. What is latency optimized, right? So you have US West 1 and US 2. There are 2 regions, 2 AZs. There are also 2 AZs are there, right? But both are separate regions. So what I'm doing here, between this is 10 milliseconds, between those 2 AZs are 10 milliseconds, right? So here I am creating a global partition and then local partitions with US West 1 and East 1. So I partition the table. I'm just making sure that my partitions are moving across. That's my leader, the follower are there in the other 2. But you make sure that the follower are closer to the same AZ where you can avoid the penalty, right? So this way, whenever I am doing my read and write, what is going to happen in this case, the replica placement is again going to be, so if you are putting, again for East also, one copy only there in West, the other copy is there in the other AZ itself. So this is making sure that you always put your replica closer to your region or closer to your AZ, so you can even making sure that you will be reducing your latency, right? So for example, the app is reading here from the West. So this access is again 2 milliseconds. It is taking from here, but it is actually doing the write also on the same data center, on the same region with the same AZ. So that means it never go to your East actually, because there is 60 millisecond penalty, right? Same for an application is doing from East. Again, East is actually doing in the same place itself. When you have to choose this design pattern, users are in multiple geos, users are in faster access, where you have an application like shopping cart or banking application, where you have to comply more, quicker read and write, right? So this will have to be carefully doing it, where applications are active in all the regions. Partition, you have to be carefully designing it. One table partition per geo, right? 2 regions per geo is recommended. Again, low latency reads are guaranteed. Lower write latency also guaranteed, because it is closer to your region itself. I mean within the AZ itself, right? So again, the factor of replication can be 3 or 5. So this I already talked and shown the demo. So yeah, so with that I think I will take any questions, please.
Any questions? Hi, thank you for the presentation. My name is Raman. One question on the consistency side, like as you split more and more masters, more and more regions for writes, then the consistency becomes, as we know, as you also spoke about, it becomes an issue. And then if we want to have consistency, and if we want to wait till the writes are spread across all masters, and that adds to the latency as well. So how are you striking the balance when it comes to consistency while splitting into different regions?
Yeah, thank you. So Yugabyte supports a two-phase commit, right? So that's a concept we follow, right? Like, for example, if I'm doing an insert, from my query layer, the insert gets fired to the node 1. The node 1 identifies based on the network parameter and the hardware parameter whether it has to get the acknowledgement from either node 2 or node 3, right? Let's say if node 3 is closest to node 1, then it will just send the request through the raft, then it will get the copy written in node 3. Node 3 has to acknowledge, then only the transaction get committed. So what is the guarantee here? Data is consistent. Even though if node 1 crashes after completing the commit, you still have the copy of the data is there in node 3. That means your app can still go and do the read and write operations with that. By the time your node 2 also get the copy because it's a R of 3, right? But for the transaction part of the quorum part, it will not wait for all the 3 to acknowledge, it will wait for minimum 2 to acknowledge. How do I decide which 2 has to be part of the transaction to reduce my rate latency? That is exactly the design pattern we had seen. Either you move the region closer, like example in Azure today we have West and Central, Pune and Mumbai, it's not going to be high latency. Or maybe US East, another US East, Central closer to the region where you don't have the latency, right? These are all the thought process we have to make sure from the location of the data center and the proximity of the application to DB, like how we can avoid that. That is one way we have to do the intelligence by our own and just put the configuration in place to do that. So this ensures the data is going to be consistent. But generally speaking, Yugabyte is a strongly consistent database. It's meant for highly available and resilient because of the raft part, right? So we don't just like that do with the eventual consistent like Cassandra or other databases. We always go for a strong consistent with the help of the two-phase commit.
Thank you.
Thank you.